Welcome to AminAcademy.com. In mathematical economics, let us discuss about optimization of multivariable functions. Here we know that the function z equal f of x comma y to be at a relative maximum or minimum, or that three conditions must be met. Here, first one, the first order partial derivative must be equal to 0 simultaneously. That means here the function z equal f of xy, then dou z by dou x equals 0 and dou z by dou y is simultaneously 0. For three conditions, in that first condition, first order partial derivatives must be equal to 0 simultaneously. And this indicates that at the point AB, any point AB, that is called critical point, is there. That means you have to differentiate partially with respect to x and y, separately equate 0 and get that point of that variable, then you can say it's a critical point. The function is neither increasing nor decreasing with respect to the principal axis, but its relative plateau. Then second condition, second order partial derivatives when evaluated at the critical point A and B must both be negative or relative max. For a relative maximum, both must be. That means you have to substitute a critical point at that function, the second order direct partial derivatives. You have to substitute the value of A and B in that. If it is negative, then we can say it's a relative maximum. That function is a relative maximum. And if positive, for a relative minimum. This ensures that from the relative plateau at A comma B, the function is concave and moving downward in relation to the principal axis in the case of maximum, and convex and moving upward in relation to the principal axis in the case of a minimum. That means we have to find second order direct partial derivatives. Then if look at here, second order direct partial derivatives, dou squared z over dou x squared, and this side is dou squared z over dou y squared. When evaluated the critical at point A and B must both be negative. At point A and B, both must be negative for maximum. This is for maximum. That is for relative maximum. For at the same time, that is here, if dou square z over dou x square at point A, B is greater than 0, and here dou square z by dou y square at the point A comma B is both are positive, then it's relative minimum. For relative minimum, here this ensures that from the relative plateau A and B, the function is concave This is concave. This is concave and moving downward. Moving downward. Here is a convex and moving upward. These are the conditions. And third, look at here one more time. You have to find the second derivative, direct second derivative, partial derivative of the function z. Then it gives dou square z over dou x square at the point a and b is negative value, that is lesser than 0. Here also for y also negative values. This is for relative maximum. And then here if then second one, if dou square z by dou x square at a b is greater than 0, this is for relative minimum. Here first one, this is the for first, concave moving downward. This is second. This we have to get it this right here better. The concave moving downward. Concave moving. This concave moving downward. This convex moving upward. Then third condition, look at here. The product of the second order direct partial derivatives evaluated at the critical point must exceed the product of the cross partial derivatives also evaluated at the critical point. This added the condition is needed to preclude point or saddle point. Preclude point or saddle point. Look at here. Here, this is concave downward and the maximum point at here is at x equals 0 and is at y equals 0. Here, this is concave upward. This is a minimum point is at x equals 0, is at y equals 0. For further, look at here. This will for relative maximum. Relative maximum. This side is relative minimum. We will discuss both here. Then first one, f of x. F of x and f of y. That means partial derivative with respect to x and partial derivative with respect to y. Both are equal 0 relative for relative maximum. And the second condition, f cross partial derivative x first f of fxx and fyy is less than 0 for maximum, and as well as third point fxx dot multiply fyy must be greater than that cross product square, then cross partial derivative square. This is a condition for this maximum. For minimum point, first condition, partial derivative with respect to x, comma, partial derivative with y must be equal to 0. Then the second point is second derivative fxx, direct derivative, comma, fyy must be greater than 0 for minimum value. And third point, second derivative, direct derivative into with respect to x, direct derivative with respect to y must be greater than f of y must be, the square must be greater than f of fxx, fyy must be greater than foy square. These points are called saddle point. Here, one more. Since, not this point, since fxy is equal to fyx, by Young's theorem, you can say fxx, fxy dot fyx equal f of xy square. Can also be written then, that is f of xx, f of yy minus f of xy. The square must be greater than 0. At this it's called an inflection point. Inflection point. When this for same sign, and saddle point and saddle point if different sign. Now, for further details, we'll do an example problem. You can understand this concept. Look at here. Now, the function z equal 2y cube minus x cube plus 147x minus 54y plus 12. This is a function. We have to find whether the function is at a relative maximum or minimum. We have to find first critical point. For critical point, we have to find partial derivative first partial derivatives zx. Zx means partial derivative of zx equal to y treated as a constant. So we have x minus x cube derivative is minus 3x square plus 147, and y is treated as constant, this treated as constant, then which must be equal to 0. Therefore, we have minus 3x square solving 147. Then x square equals minus 147 over minus 3, which is equal 49. Therefore, x equal to square root of 49, which is equal plus or minus 7. Then this side zy. Here zy means we have to treat x as a constant. Y differential of 2 y cube is differentiation is 23 6 y square. This x is a constant, treat constant. This constant minus 54 differential equals 0. Therefore 6 y square equal 54, y square equal to 54 over 6, 9. Then y equal square root of 9 is plus or minus 3. So we have x is plus or minus 7 and y is plus or minus 3. With x equal plus or minus 7 and y equal plus or minus 3, there are four distinct set of critical points. Therefore, critical points are what? X is positive, 7, 3, 7 minus 3, minus 7, 3, minus 7, minus 3. These are four critical points. Now we'll consider the second order partial derivative. Second order partial derivative, that is, we have to get it z direct derivatives z xx. Here we have zx equal minus 3x squared plus 147. That is further differentiation which gives minus 6x. Here z yy direct derivative is, look at here, this one is 6y squared minus 54, then 12y. We have two things. First, we'll consider each point. First, zxx at point 73 gives, so we have to get it x equal to 7 minus 48. So 6 into minus 6 into 7 is minus 48. Then zxx, the point is 7 minus 3 is also x value is 7 minus 48. Then zxx at point minus 7 and 3. Look at here. Here is a xx is minus 6x, minus into positive. The 6 ends are 42. Not 48, is 42. This is plus 42. Then another fourth one, zxx at minus 7 minus 3, also 42, because they are minus, x is minus 7. So these are this greater than 0, this greater than 0. Similarly, for zyy, first zyy at 73, where y value is 3, so 3 12s are 36. Zyy at 7 minus 3, here y is minus 3, so we use minus 36. Then third, zyy at minus 7, 3, minus 1, 3 is what? Here 36. And fourth 1 result yy minus 7 minus 3 is minus 36. We are alternately changing. Look at here, it's a positive, it's negative, it's positive, it's negative. From among this result, what you understood here is that xx is this at different points. We have this conclusion here also, this conclusions in that since there are different signs for each of the second direct partial derivatives 1 to 4, the function cannot be a relative maximum or relative minimum. The function cannot be a the function therefore the different signs second partial derivatives 1 to 4, the function cannot be a relative maximum or relative minimum. Relative cannot be a relative maximum or minimum at 7 3 and or minus 7 minus 3. That means here 7 3, look at here, this 7 3 is negative, this 7 3 is positive. That both are changing signs. So next condition, when f of xx, secondary f of xx and f of yy are different signs because of one has different signs, different signs. Therefore, you can say and function is saddle point. Therefore, these are saddle points. And also it's a saddle point. That means the saddle point condition is fxx into fyy, the product of these two things cannot be greater than f fxy the square. So it's a saddle point. When both signs of the second direct partial negative in 2 and positive in third, the functions may be at relative maximum. Therefore, at 7 comma minus 3, relative maximum at relative maximum and minus 7 and 3 relative minimum at relative minimum. So far we discussed about that is optimization of second order derivatives. That means optimization of multivariable functions. In that will be one example problem also we have done. Please subscribe our YouTube channel.